Now let's talk about compound interest. And I'm interested in interest, not because I'm interested in it for its own sake. This is not an accountancy course, but we're using this as an example of a complex exponential function. So we've got an x value in an exponent, but it's more complicated than simply 2 to the power x, something like that. So let's have a look at the equation for it. So I won't expect you to know this off by heart, but I would expect you to be able to use it if I gave you the equation to remind you of it. So got a equals p times 1 plus r over n to the power nt. And this is how your compound interest at the bank is calculated. So a is the ending amount. So that's probably what we're trying to calculate. P is the principal, which is the starting amount. So that's the amount that you put into the bank. R is the annual interest rate. Annual interest rate. N is the number of what we call compoundings per year. So so it can be that interest is added to your account every day, every month, every year. So this is per year. Quite often it's added every month to your account. So then n would equal 12. So that's right there. If monthly n equals 12. And then finally t is the total number of years. And obviously this doesn't have to be a round number. Okay, so let's have an example. Let's imagine we've got a loan with £1,000 principal, an interest rate of 1.5%, which is 0.015, n equals 12, so that's monthly. So f of x equals 1,000 times 1 plus r, which is 0.015 over 12 to the power 12x. So it's this. So our ending amount a will depend on the amount of time that goes past, and you'll see that this x is in the exponent. So let's just do a couple of examples. So after 2 years, with your £1,000 in the bank there, a is equal to 1,000 times 1 plus, if we divide these together, we see it's 0.00125 to the power 2 times 12, because our x is the amount of time in years, so that's 2, and that is 1,000. If you 1,000 times 1.00125 to the power 24, and so that gives us £1,030.44, which doesn't sound all that impressive. But how about after 100 years? So then a is equal to 1,000 times 1 plus 0.00125 to the power 1,200, and that gives us £4,477.49. So that's just some evidence to prove that we should become vampires, and then we can all be fabulously wealthy.